15. The differential pressure flowmeter. Hello, everyone. In this lesson, we will learn the differential pressure flowmeter. Differential pressure flowmeter is a kind of flowmeter with a long history, mature technology, and wide application. Differential pressure flowmeter can be divided into throttling type, dynamic head type, hydraulic drag, centrifugal type, dynamic pressure gain type, and jet flow type according to the working principle of its detection parts, among which throttling type and jet flow type are the most widely used. The throttling type is characterized by simple structure, long service life, strong adaptability, and can almost measure the flow under various working conditions. First, we learn the composition of the differential pressure flowmeter. Differential pressure flowmeter is based on the principle of throttling to measure the flow rate and is composed of a primary and a secondary device. The primary device is called the flow measurement element, which is installed in the pipeline of the measured fluid, and the pressure difference is proportional to the flow rate for the secondary device flow display. The secondary device is called the display instrument, which receives the differential pressure signal generated by the measuring element and converts it into the corresponding flow rate for display. The primary device of the differential pressure flowmeter is usually a throttling device or a dynamic measurement device. The secondary device is various mechanical, electronic, and combined differential pressure flow meters equipped with flow display instruments. The differential pressure sensitive elements of the differential pressure flowmeter are mostly elastic. Due to the relationship between differential pressure and flow rate is quadratic, the flow indicators are equipped with quadratic roots exaction devices to linearize the flow scale. Most meters are also equipped with flow measurement devices to display integrated flow rate for economic accounting. This sensor is used to measure the flow rate of main steam, water supply, condensate, and so on in power plants. It consists of three parts: 1. A throttling device which converts the measured value into differential pressure value. 2. Signal transmission link. 3. Differential pressure flowmeter or differential pressure transmitter used to detect differential pressure and convert it into 4 to 20 mA standard current signal. The output signal of the differential pressure flowmeter indicates the instantaneous flow rate through the display indicator. The flow rate is measured through the calculator, and the flow rate is controlled through the control device. Then, we learn the measurement principle of the differential pressure flowmeter. When the fluid that fills the pipe flows through the throttle in the pipe, the flow rate will shrink locally at the throttle. And when the flow rate increases, the static pressure will decrease, so there will be a pressure difference before and after the throttle. The larger the fluid flow, the greater the pressure difference generated, so that the flow rate can be measured according to the pressure difference. This measurement method is based on the fluid continuity equation, the law of conservation of mass, and the Bernoulli equation, the law of conservation of energy. The size of the pressure difference is not only related to the flow rate, but also related to many other factors. For example, when the form of the throttling device or the physical properties, density, viscosity, of the fluid in the pipeline are different, the pressure difference produced under the same size of flow rate is also different. Next, take the orifice plate as an example to explain the basic principle of the throttling device to measure the flow rate. The steady flow of fluid flows through the pipe in the horizontal direction, and a throttle orifice plate is installed in the middle of the pipe perpendicular to the axis. The fluid flows at a certain velocity v before section 1.1, and then the flow beam begins to shrink, and the fluid near the pipe wall begins to accelerate towards the center. Due to the head-on resistance of the orifice plate, the hydrostatic pressure along the pipe wall gradually increases. As for the stable and continuous fluid, the amount of fluid passing through each section of the pipeline at the same time is equal. So the reduction of the flow section will lead to an increase in flow velocity, that is, an increase in kinetic energy. According to the law of conservation of energy, the sum of the static pressure energy and kinetic energy of a fluid plus the energy lost to overcome flow resistance is invariable. For the ideal fluid, without considering the energy loss, the increase of kinetic energy will inevitably reduce the static pressure energy, so the pressure in the center of the flow beam will decrease accordingly. Due to inertia, the flow beam continues to shrink after passing through the orifice plate and reaches the minimum at section 2-2, at which the flow velocity is the maximum and the static pressure is the lowest. In this way, there is a static pressure difference before and after the orifice plate. And the greater the flow rate, the more significant the local contraction of the flow beam and the conversion of potential energy and kinetic energy. And the greater the pressure difference before and after the throttling device. Therefore, the flow rate can be obtained by measuring the pressure difference, which is the basic principle of the throttling device to measure the flow rate. Finally, let's learn about the throttling device. The throttling device of throttling differential pressure flowmeter can be divided into two categories, standard and non-standard type according to its standardization degree. The so-called standard throttling device refers to a device that is designed, manufactured, installed and used in accordance with standard documents, and can determine its flow value and estimate flow measurement errors without actual flow calibration. Non-standard throttling device is a test piece with poor maturity and has not been included in the standard document. The complete throttling device consists of three parts: throttling element, pressure-taking device, and upstream and downstream measuring conduit. Today, we learn the basic concepts, the measurement principle of the differential pressure flowmeter, as well as the throttling device. After class, you can search information to learn what are the industrial applications of differential pressure flow meters. This is the end of this lesson. Thank you.